everybody, Mr. Covey here, and I'm going to go over with you guys how to solve exponential equations, okay? So keep in mind these are exponential equations in the sense that the variable is in the exponent, okay? That's why they're exponential equations. There's really two different main scenarios, scenario 1 and scenario 2. The approaches for those two different scenarios are very, very different. And within scenario 1, you can kind of think about like little sub-scenarios that kind of use different ideas. But basically, there's two big ways to solve exponential equations. Let's dive right in, and I'll come back to why the Kool-Aid man is chilling over here. So if you look at this first equation, there's something nice about the numbers. 4 to the negative x minus 3 equals 16. There's something nice about the numbers. I hope when we're thinking about exponents, we see that, we're like, oh, yeah, 16 is 4 squared. And that's just like a fact that we know. And the reason that's nice is because then we have an exponential equation that looks like this. What's nice about this equation? Both sides have the same base, okay? If you have an exponential equation where both sides have the same base, it's easy. I like to say, same base, oh yeah. Say it with me, it's helpful. Same base, oh yeah. When I see that same base, that means it's going to be easy. If both sides of my equation have the same base here, both these are 4 to something equals 4 to something, the equation is going to be easy to solve, okay? All you got to do then is set the exponents equal to each other. Hey, if 4 to some power equals 4 squared, well then the power on the left, the negative x minus 3, has got to equal 2. And then I just solve this equation. Easy, done. Cool. Same base, oh yeah. That's good. Here, I just have to recognize that 16 was 4 squared. If you can make them the same base, oh yeah, it's going to be easy to solve. Okay, this one, take a look here. A little bit trickier. Okay, but 16 and 64 aren't completely random numbers. It's not like 12 and 92, 3, you know what I mean? They have something in common. What do they have in common? They're both powers of 4. So I can rewrite that 64 as a 4 to the third. So I'd have 4 to the third to the negative x. And I can rewrite that 16 as a 4 squared to the 3x minus 2. Why am I doing this? Because I want it to be same base, oh yeah. Okay, I really want same base, oh yeah. Because it makes my life easy. I just set the exponents equal to each other. Okay? So here, I'm doing a little bit of rewriting, using a little bit of exponent rules, properties that I know, in order to make it into same base, oh yeah. So that's why it's still scenario 1, which is same base. You want them both sides at the same base. Be careful about the exponent properties here. 4 to the third to the negative x, what do you do with an exponent to an exponent? You multiply them. So this would be 4 to the negative 3x equals, be careful here, 4 to the second to the 3x minus 2, I need to multiply, 2 by 3x minus 2, and so I need to distribute it. Very important there, pay attention to that part. Okay? That 2 applies to both those there. So I get 4 to the 6x minus 4. And now, same base, oh yeah. Hope you guys know who the Kool-Aid man is. If you don't, listen out, look it up online. Alright, same base, oh yeah, set the exponents equal to each other. Easy peasy, doesn't get any better than that. Solve that out, I get 9x equals 4, I get x equals 4 ninths, and I'm done. Okay. Last one here, similar. I'm going to be able to make this into same base, oh yeah. Got to be a little more careful here with my exponent properties. Why don't you pause and try and get it to be 4 to some power equals 4 to some power. Get both sides to have the same base. Pause and give that a try. Okay, I hope we're feeling okay about exponents in general. 1/16 is 4 to the negative second. If I'm multiplying two things with the same base, what do I do with the exponents? I add them together. So I get 4 to the 3x equals 4 to the negative second. I just made this look just like this. Okay. Hey, same base, oh yeah. Just set the exponents equal to each other. 3x has to equal negative 2. X equals negative 2/3. Here, I guess I'm just using different exponent properties, but it's all under this umbrella of getting both sides to have the same base. Okay? Keep in mind we are solving equations. So after you solve an equation, if you want to plug your solution back in, it should make both sides equal. That's always true for solving equations. So keep in mind that's something you can do. Okay? Now, all three of these fall into the category of same base, oh yeah. It is actually not really typical, right? Because if you look back at this first equation, it was like super nice that the 16 was 4 squared. If I change that 16 to a 15, I don't know what to do. If I change it to a 17, I don't know what to do. Okay, so like most of the time, you're not going to be able to get same base. Let's look at one here. So I have 3 to the negative 5x plus 7 equals 30. I'm going to subtract the 7 over. Check. I hope you're like, algebra sense is saying that's definitely a good thing to do. So I'm here. Now I'm like, oh, I want it to be same base, so yeah. So I have 3 to some power on the left. 23, 3 to some power. No. Okay, so I'm kind of stuck here. This is where I got to whip out the big tools, the big math tools. I know what you're thinking. I haven't even touched what yet? I haven't even talked about logarithms, okay? This is what logarithms were built for. I need to undo this exponentiation I see here. I need to use logarithms to help me solve this equation. I cannot make it same base, oh yeah. So this is called different base, oh no. Okay, this is not same base, oh yeah. This is different base, oh no. Okay? I can't write 23 as 3 to some power. It is 3 to some power, but I just have no idea what power it is. 3 to the 2.825, I don't know. So instead, I need to use logarithms. Okay? Remember, logarithms undo exponentiation, so it should make sense that we're using logarithms here. There's kind of two ways to think about this algebraically, and I'm going to show you both ways, and then I'm going to say you can totally choose which way makes more sense to you, or which way your AAA teacher did it when you originally learned it. Way one is to take this equation, and both of these ways are totally going to give us the same answer, and to do the log of both sides. I need to use logs here. So I'm trying to undo this exponentiation. And what I do to one side, I have to do to the other. So I'm going to log both sides. And specifically, I'm going to log base 3 both sides. Why log base 3? Well, because I had a 3 to the. My base of my exponent was 3. On the right side, log base 3 of 23 is a number. Type in your calculator log base 3 of 23. Check. You should keep this value in your calculator for now, but I'm just going to round it here. On the left side, look at what I have. I have log base 3 of 3 to the negative 5x. Remember what a log says? It says, this to what power is this? Think about it for a second. 3 to what power is 3 to the negative 5x? Well, that's just negative 5x. Okay? Another way to think about it is this log and this exponent cancel each other out. Why? Because they both have the same base. So here, I took the log base 3 of both sides to get to this point. Okay? The other way to think about this is to look at this exponential equation and to convert it to log form. Yeah, I'll say that again. Is to look at that equation and convert it to log form. What does that mean? Well, you remember, these two things are equivalent. This exponential equation is equivalent to this log equation. So I can take this exponential equation and make it into a log equation. I can convert it to log form. If you do that, well then the base of my log would be 3. The argument would be 23, and it would equal negative 5x. Well, what's log base 3 of 23? 2.85405 equals negative 5x. Either way of thinking about it, you get to the exact same place. So you can do it however you want. You can log both sides, do the log of both sides, or you can convert it to log form. The idea is the same. Okay? We're not done solving this equation. Regardless, we have one more step. The x isn't by itself. Remember, we're solving the equation. We want to get the x by itself. What do we got to do? Divide both sides by negative 5. Okay? It's nice to keep that value in your calculator, that log value, so that you can get an exact answer and don't have any rounding issues. I got to be getting negative 5.71. I'm going to round to 3 decimal places there. Okay? Check. Cool. Okay. So in a quick summary here, some exponential equations, you can make them have the same base. They're called same base, so yeah. Sometimes you have to use exponent properties. Sometimes you have to combine two things together. But as long as you get both sides that have the same base, then you just take the exponents, set them equal to each other, and solve. However, a lot of exponential equations, you can't make both sides have the same base, or at least we don't know how. So when you hit a scenario like this, different base, oh no, that's where you have to grab the logs, okay? And you either have to log base 3 both sides or convert it to log form, however you want to think about it, but you need to use logs, and the log that you're going to use is going to have a base that's the same as the base of the exponential that you see. Okay? All right, I'm going to pause there. Thank you guys for watching.